All right, I'm going to go over the explanations to the review sheet for your quiz that will be coming up on Friday. All right, so as we are doing these, we want to look at some of these problems. You're going to be able to do it the way we did in the past. All right, but anytime you see a parentheses raised to a power, you're probably going to have to use substitution. Okay, so whatever is on the inside is going to be our u. So our u is 6x squared minus 5. All right. Then my du, to take the derivative of that, that is going to be 12x dx. We then check. We need all of the du needs to be in here. All right. Remember, we can't add variables. So if this x isn't somewhere, we're done. But it is. It's right here. There's an x. There's dx. I'm missing a 12. So I have to add a 12 in, which means I put a 1/12 on the outside of the integral. All right, all of this is my du, and this is my u. So it's u to the 8th du, 1/12. So I integrate that 1/12 times u to the 9th over 9 plus c. So my answer is 6x squared minus 5, because I'm just substituting my u back in there, to the 9th, all over 12 times 9, which was 108, plus c. There you go. There's number 1. All right, number 2. There is no quantity raised to a power. There is no trig. This is just take the integral of this, this, and this, just like we've done before in the past. All right, so this is 5x to the 5th over 5. My 5s are going to cancel, plus x squared over 2 minus 10x plus c. So it's x, it's x to the 5th plus x squared over 2 minus 10x plus c. And there's our answer for number 2. We're not going to have to do substitution with all of it on this quiz for every single problem. There will be a couple. There will be one where it's just a basic do all the power rule to it. Okay. This quiz is very, very similar to what, this review is very similar to what you should expect on your quiz. All right. Excuse me. All right. So now, when we do a trig problem, okay, when we do a trig, unless it's just a trig with an x after it, you're going to have to use substitution. If you only have one trig function, for example, this one right here, we just have cosine, you make u whatever comes immediately after the trig, and that's it. There's no trig involved in the u. So in this problem, there's only one trig function. We take x to the 8th because it comes immediately right after your cosine. So it's u equals x to the 8th. I then take the derivative of that, which is, sorry, I screwed up there, 8x to the 7th dx. All right. Now, we need all of this. Remember, you can't add in variables, but there's the x to the 7th. There's my dx. I just need to add it 8. So I get a 1/8 on the outside integral. So that's gone. That's my du. All right. Cosine x to the 8th is cosine of x to the 8th, but it's u. So it's 1/8 integral of cosine u du. Hopefully you know what cosine u du is. All right. However, remember, we can use our formula sheet. All right. And you look for the integral of cosine u du, which is right there, which is sine u plus c. All right. Which is sine u plus c. So it is 1/8 sine u plus c. So it's 1/8 sine of x to the 8th plus c. You could also write this as sine x to the 8th all over 8 plus c. Both work just fine. All right. All right. 4, once again, we only have one trig function. Doesn't matter that it's squared. If you just have one trig function, you make u whatever comes immediately after it. So u equals 9 to the x. All right. 9x, not 9 to the x. The derivative of that is 9 dx. I don't have a 9, so I have to add a 9. There, right there is my du. So 1/9 integral secant squared 9x, which is u, du. Right? Hopefully you know that's tangent. If you didn't know it was tangent, you would just go here and look, where's my secant squared? Oh, there it is. Secant squared u du is tangent u plus c. All right, so it's 1/9 tangent u plus c. So it's 1/9 tangent of 9x, because I just take the 9x and substitute in for u, plus c. There's your answer. All right. Scroll down here to 5 and 6. All right. Now, 5 is another example where you're not going to have to do substitution. All right. This is the kind where you have to split this up first. So you first do the integral of x to the 5th over x to the 5th, which is just 1. All right. They cancel out. Minus x over x to the 5th. That's 1 over x to the 4th, which is really x to the negative 4th. All right. And now we just integrate each of these. That's x minus x to the negative 3rd over negative 3 plus c. So my answer is x. The two negatives makes it a positive. This I'm going to move to the bottom. So it's 1 over 3x cubed plus c. All right. So you're definitely going to have one like this where you got to split up. All right. And you're definitely going to have one like number 2 where you don't have to do any substitution. All right. 6. All right. For number 6. All right. So this is the first one we have. We have 2 trig functions. 1, 2. Both have the same thing after it. Now, what you have to do is look at the powers. You see how exponent there is a 1 and there's a 1, which means that they're the same power, which means we still just pick whatever comes immediately after it, which is, this case is the square root of x. All right, that's what our u is. So to find du, remember the square root of x is the same thing as x to the 1/2. All right, so when I integrate that, that is x to the, if I take 1 away, the 1/2 goes on the outside. It's 1/2 x to the negative 1/2, which is the same thing as 1 over 2x to the 1/2, which is the same thing as 1 over the 2 square root of x. Right? X to the 1/2 is root x. All right, so this one's a little bit different. We need all of du in here, right? There's our dx. There's our root x on the bottom. We're good. What are we missing? We're missing a 2 here on the bottom. So what am I going to put on the outside of the integral? I didn't add really a 2. I had 2 in a denominator, which means I really added what? 1/2. So what's the reciprocal of 1/2? 2. So I need to add a 2 to the outside of this. All right. So I got 1 over 2 root x dx. That's my du. I then have cosecant of square root of x, which is just u, cotangent u. All right. So you have 2 integral cosecant u, cotangent u. Hopefully you know what that is without looking at the formula sheet, but you can look at the formula sheet. And where do you look? You look at the integral. Where do I find it? Where do I find it? Oh, there it is. The integral of cosecant u, cotangent u is negative cosecant u plus c. All right. So it's negative 2 cosecant, whoops, that's not a c, cosecant u plus c. So the answer, negative 2 cosecant, what was u? The square root of x. If you put x to 1/2, that's also fine, plus c. And there you go. All right. All right, 7. 2 trig functions. One is bigger than the other. They're not the same power. This is 1, that is 4. So it's the first one now where we have 2 trig functions, different powers. You pick the trig function with the highest exponent. So that is cosine 3x, and you put the trig inside your u. That's when you use the trig inside the u, is if it has 2 and it has a higher exponent. All right, two trig functions, different exponents. So I take the derivative of cosine. If you forget what the derivative of cosine is, you can look right here. It's negative sine u du. So it's negative sine 3x times the derivative of that, which is 3 dx. Okay. Remember, we need all of du in our problem. We have sine 3x dx. I'm missing a negative 3. So there is my du. So I'm going to add a negative 1/3 to the outside. Integral of du over cosine 3x is u. U to the 4th, which is really 1/3 integral of u to the negative 4th du. So then we just integrate negative 1/3 u to the negative 3rd over negative 3. All right, negative times a negative is a positive. All right, and we're going to move this to the bottom. So it's going to be 1 over, all right, 3 times 3 is 9. 9, and then it's u to the 3rd. So it's cosine 3x to the 3rd power plus c. Now, the 3 you can also put right here and not write it that way. If you wanted to write it like this, cosine cubed of 3x. You also can write that way. Either way is going to be fine. I don't care. All right. 8. Same thing. We have 2 trig functions. So my u is going to have, and they have 1, 7, and that's a 2. They have different powers. One of these, this u is going to have a trig in it. So which one's the highest exponent? 7. So I'm going to take tangent of 2x. I'm then going to take the derivative of tangent, which you can look at your formula sheet. The derivative of tangent is secant squared. So it's secant squared 2x times the derivative of the inside, which is 2 dx. Don't forget about chain rule. All right, derivative of the outside, keep the inside the same, times the derivative of the inside. That's where that 2 comes from. All right, so I need all of this. Well, here's secant squared 2x. Secant squared 2x dx. I'm just missing a 2. So I need to put a 1/2. All right, all of this is my du. Tangent 2x is my u. So it's just u to the 7th du. All right. And I've mentioned this before, but just notice again. In the problems where I have trig and I just use u as whatever comes after it, when I rewrite the integral, I still have the trig there. No trig, trig. The ones where you have trig in the u, there's no trig in the integral. All right, and that normally happens a lot. All right, that's really what happens. Integrate 1/2 u to the 8th over 8 plus c. So I get tangent to the 8th power of 2x all over 2 times 8, which is 16, plus c. If you want to write this as 1/16 and then write tangent 2x to the 8th power plus c, it's fine. All right. All right, so that's number 8. All right. Number 9, which there was 2 problems on here we weren't going to worry about. I don't know if I told you that. I don't think I told you that in the assignment. We are not going to right now worry about number 9, and we're not going to worry about number 11. All right, we're not going to do 9 or 11. Okay, because there's not really ones like that on the quiz, and do Pythagorean identities. We're not going to really deal with that. Okay, so we're just going to move right along to number 10. All right, so here we have the good old trig in the bottom. All right, hopefully you remember your reciprocals. If you have cosine in the bottom, what is 1 over cosine the same as? 1 over cosine x is the same as secant x, which means 1 over cosine squared is the same thing as secant squared. So this is secant squared 9x dx, which I believe then just turns into the same problem, I believe, as number 4. All right. So, oops, where did I go? Oh, just lost all my writing. Okay. So this is the integral of secant squared 9x. All right. And then the u, it's one trig function, is 9x. Du is 9dx. All right. I would add, whoops, there should be a dx here. So you have to add the 9 in. All right. 1/9 integral of secant squared u du. The integral of secant squared is tangent. So it's 1/9 tangent u, which is 9x plus c. The reason I rushed through that one is because once you get to this point here where I rewrote it, it's the same problem as number 4. All right. It's the same exact problem as number 4. You just have to realize that reciprocal, you could change that. Okay. All right. Like I said, we are not going to do 11. All right. 12. All right. 1, 2. Two trig functions. Which one is the higher? They're different, 7 and 2. I'm going to take the one with the higher exponent, which is cosecant. All right. So it is, u is going to be cosecant 4x. The trig is involved. Now, do I need to put the negative in there? No. But if you do, it's not really going to change anything. You'll see why. So I take the derivative of cosecant 4x. You can look at your formula sheet. Derivative cosecant is negative cosecant cotangent. Right? So it's negative cosecant, whatever comes after it, inside stays the same. Cotangent, whatever comes after it, stays the same, which is 4x, times du, which is the derivative of what's in the inside, which is 4 dx. Okay. Now, you don't need to add the negative because we have the negative there. All right. So we need all of this. So I have this is a typo. This is not supposed to be there. Yep. I remember this now. All right. This was not supposed to be on your original. So if it was, I don't know if it's on yours. Hopefully it's not. If it is, sorry, that's not supposed to be there. Otherwise you guys can't do this problem. All right. So let's pretend that cotangent is not squared. All right. It is just to the first. All right. So I have cotangent 4x. I have dx. I'm missing a 4. So I have that. Put a 1/4 here. Then I still need a cosecant 4x. Well, here's cosecant 4x. So I'm going to take one of those. This is the ones where now this is not a 7. I now make that a 6. All right. That is now a 6. All right. So what I'm left with, this negative is also part of my du. So I'm just left with u to the 6th du. All right. So this is the kind where we have the du includes something that's part of the u. So I just take one away from the exponent. All right. Sometimes you see this with secant and tangents. All right. There definitely be one of these on the quiz. You've had a few of those on the worksheets as well. All right. So now I just integrate this and I get 1/4 u to the 7th over 7 plus c. So it is cosecant 4x to the 7th. Whoops. All over 28 plus c. All right. So this problem was a typo. This should have just been 4x. Otherwise, you're quite frankly not going to be able to do the problem. All right. All right. So let's scroll down here to the last few problems. All right. All right. We have something inside a radical. All right. So this is the same thing as x minus 2 to the 1/4. All right, so I'm going to make u whatever's on the inside, which in this case is x minus 2. What is the derivative of x minus 2? It's 1, so it's just dx. So I don't need to add anything. So this just becomes u to the 1/4 du, right? Because I don't need to add anything here. The dx is already there. There's no 4, 3. There's nothing to add. All right, so it's u add 1, which would be 5 over 4. Take the reciprocal, so 4 stays there, 5 goes in the bottom, plus c. So the final answer is 4 parentheses x minus 2 to the 5 fourths all over 5 plus c. All right. Switch colors. All right. Now, 14. Quantity raised to a power. So pick whatever's on the inside. 5x to the 4th minus 2. The derivative of 5x to the 4th is 20x cubed dx. All right. I need to have all of this. I have my x cubed. I have my dx. I'm missing a 20. So I add a 20 to the top, which is 20 over 1. So then I need to write it 1 over 20. All of this is my du over x to the 8th, which is the same thing as 1 over 20 integral of x to the negative 8th du. All right. Get a little cramp in my arm here doing this mouse. All right. So integrate this, and I get 1/20 x to the negative 7th over negative 7. Then I have to move this to the bottom, right? So it's 1 over 7 times 20 is 140. 5x to the 4th minus 2 to the 7th power plus c. All right. Last one. All right, last one. So in this problem, we have a quantity raised to a power. So you're probably like, I'm going to go ahead and do u. U is 2x cubed minus 1. The derivative of that is 6x squared. What's the problem? Well, the problem is I can't add in. I can put a 6 out here, but I cannot put in the x. All right, I can't put that in. So I can't do it this way. All right. So you then just have to do it the old school way, which is to FOIL this out. Now notice this one's only a squared. I won't do this to you if it's a cubed, a 4th, and a 5th. It would be just a squared. So if there's a problem that's quantity squared and you can't do it by u and du because you would have to add a variable, just FOIL it out. So this is now the integral of 4x to the 6th minus 4x cubed minus 1. Then just integrate each of these. 4x to the 7th over 7 minus 4x to the 4th over 4 minus x plus c. Those cancel out, and there's your answer. 4x to the 7th over 7 minus x to the 4th over 4 minus x plus c. All right. And there is your review, which, like I said, is going to be very, very, very similar to the types of problems you're going to see in your quiz on Friday. I'll probably give you some extra problems tomorrow. But this is what, if you're studying, you should really, really concentrate on. Okay. If you go back and look at it, there was only, I think, 3 problems on here that we didn't do substitution on. Probably going to be very similar on the quiz. Types of trig problems. Some where there's, make u what comes after it. The other ones you have to make trig in it. Sometimes it's on the bottom. All the types that you had here is what you should expect to see for your quiz on Friday, which will be part of the 4th marking period. All right. The 3rd marking period grades are pretty much done quiz-wise. I'm just going to put some classwork grades in. This will be your first significant grade of the 4th and final marking period. All right. Hope you guys are all hanging in there, and I will talk to you soon.